Good afternoon, ladies and gentlemen. My name is Graham Foster. I'm the Technical Director of Marine Power Systems, and I'm going to share with you a little bit of an insight into the journey that we've taken from the first conceptual design of the WaveSub and through to our plans to the first array. So before I start, just a little bit of an introduction to the WaveSub. The WaveSub is a novel wave energy converter that has a number of USPs that we hope will address the fundamental issue in wave energy and all marine energy, which is generating energy at a low cost and competitive with other forms of generation. So to do this, we believe that it's important to address the four fundamental challenges of wave energy. These are really the energy capture itself. The energy in waves is a subsurface orbital energy flow. So that's a difficult energy flow to get at efficiently. So that's the first challenge. Survivability is the obvious challenge. The conditions are obviously very harsh during severe storms, which is the kind of conditions we can expect in the sites that we choose to put these devices. Transportation, operation, and maintenance, again, a huge challenge. The devices really are going to struggle to generate energy at a low cost if very expensive pieces of equipment are needed every time an intervention is needed on site. And of course, the capital cost of the device itself, so the device needs to be inexpensive to manufacture in relation to the power it produces. So we believe at Marine Power Systems that no existing device fully addresses those challenges. And just to put that in a little bit of context, the challenges I've talked about aren't some sort of esoteric nice-to-haves. We believe that fundamentally they feed into the root of the cost of energy equation, and all of the things that I've talked about actually turn up in the cost quite directly if you just have a little look at it. So going on to the WaveSub, the talk I'm giving is the journey from concept through to the first array. So starting out with the concept, the main thing that we wanted to do at Marine Power Systems was properly address those challenges. So the WaveSub addresses them as directly as we possibly think that it's any device can. So the first one is the efficient energy capture. The WaveSub harnesses the orbital energy flow with a subsurface orbiting float. The second USP of the WaveSub is that it optimizes the power output by being depth adjustable. So it can adjust the depth that it sits at depending on the ongoing conditions, and by doing that we adjust the device not just to the wave size but also the wave period. The device also has a floating surface configuration and a submerged operating configuration. In the device's floating surface configuration, it's its own deployment system and transportation barge. This makes it very easy to transport long distances and access for service and maintenance. Finally, the device is geometrically simple. It's protected from ever experiencing large loads, and it's small for the amount of power it produces, so it's got a low structure cost. So that was our starting point really on this journey from concept to array, was to really put the effort into getting the concept right initially, and then we believe that having done that well, it'll speed the journey through to a commercially acceptable device. So up until today, there's a number of things that we've done in the history of MPS. The things that we've done a lot of are tank testing at small scale and also computational modeling. We put an awful lot of effort into those two things, and that's helped us understand the fundamental physics of our device, and it's enabled us to understand the likely performance we're going to get at full scale. It's the combination of those two things has then allowed us to come up with some cost of energy predictions. Obviously, any predictions about cost of energy at the stage we're at are difficult, but we do believe that even with very conservative estimates, we can get the WaveSub to a place where the levelized cost of energy will be acceptable in the future. So where we are today, after having spent a lot of time doing really understanding the system with the modeling and the tank testing, we're now at our quarter scale demonstrator phase. Right now we're finalizing the design of the quarter scale prototype, and we're in the procurement stage with a lot of the parts of the system, and we expect to be manufacturing the device over the summer and deploying towards the end of this year. The first part of the deployment will be in Milford Haven Port, where we'll be doing sort of deployment testing. We'll be towing the device, simulating deployments, simulating maintenance, doing that in a controlled environment here in Milford Haven Port, close to where we're going to manufacture the device in case anything comes up in that testing. And then we'll be going down to fab test to do the operational testing where we'll watch the device for over many months, up to a year, and generate energy with the machine. So essentially, with this testing phase, we want to really prove the USPs of the WaveSub, want to prove the maintenance and the survivability, and ultimately feed that back into our cost of energy estimates and hopefully get some more good news about the potential of the WaveSub at larger scale. So that's where we are today. And again, continuing the journey to arrays, the next step on that is a full-scale demonstrator. So essentially, we expect to be mostly upscaling the quarter scale prototype. The effort really is going in now into designing the system. We're making sure that the system really is a small-scale version of this full-scale device. So all of the capability that we'd need for grid connection, etc., of the full-scale device, we are replicating that right now at quarter scale. So we're bringing forward all of the challenges we're likely to expect at full scale and trying our best to resolve them now. The other things we'll be doing is developing the second generation of the WaveSub. So we've already identified ways to make the WaveSub more economical in the future with larger devices, with different materials. So there's lots of work going on there, and that work will increase as we get to the end of the design phase of the full-scale design. So the full-scale testing, we're going to initially deploy one device, hopefully at the South Pembrokeshire demonstration zone. Everything's looking good for that at the moment, so that's where we want to deploy the first full-scale WaveSub. And because the demonstration zone obviously has the capacity for many megawatts, we expect then to be able to build and deploy the first array alongside the initial full-scale demonstrated device. So hopefully we'll just get confidence with the first demonstrator and then basically build out a farm alongside that first full-scale device. So that's it really. I hope that was a neat little summary for you of the journey that we're in the process of taking from the concept of the WaveSub and through into the future for the full-scale device and our first array. So thank you for your attention.